Okay, let's have a look. All right, can everybody see this okay? Get where you can see. I want to look at some stuff, kind of, we talked about yesterday. I'll give you, today's last day in the classroom for the week. The rest of the week, you can work on stuff, retake tests. I wasn't going to do this, but I've had such a hard time getting these assignments built. It's taken forever to build these transformation assignments. I will definitely get them done though. I mean, tomorrow I know you're kind of stuck, not stuck, it's gonna be a good thing. You're gonna be in the career day stuff, but what I don't have done by tonight, I'll for sure get done tomorrow. And so I'll put all the transformation assignments up through section 7.4. Will be up, in the next day or two. Okay. So because I don't have 7.2 ready to go, what I want to do is maybe continue what we talked about a little bit yesterday, and then move on to rotations a little bit. There's some really cool properties of rotations. I want to see if you guys can see. Yesterday we looked at reflections, right? And tell me what you know about reflections. What do you know about reflections?
It's like it's a shape next to a mirror.
It's like
Yeah.
like properties.
Yeah, just tell me some things. Just tell me some stuff about reflections.
It's over the y-axis, like the x coordinates.
Okay, good. So we know some specifics about reflecting over x and y axes. Okay, what else do we know about reflections? Ellie, you have your hand up. Do you have something else? Oh, that's what he said. Okay.
Like depending on like the line that it reflects over, each point is like the same distance.
Okay, good. So we know that for every point that's reflected over the line of reflection, right? You know that it has to obey the property where it's the same distance away from the line. And what else do we know about that? Yes, ma'am.
It's always the same side.
Okay, it's an isometry. Very good. So it's an isometry. It doesn't change. The measurements all stay the same. Jill?
It's a 180-degree rotation, right?
It's, well, we'll hold that thought. We will look into that. That's an interesting thought.
Doesn't the line of reflection always bisect with creating
Good. Okay, so and this really summarizes the whole thing. For every point that's reflected, the line of symmetry is a perpendicular bisector of the segment formed by the image and the pre-image, right? And so we looked at some pictures yesterday. We represented that like, what's going on? Oh, serious? Why is it doing this? Oh, I think darn it. Okay. Okay, yeah, so we said, for example, if we have, a point, call it point P, and we have some line of reflection, then we know that point P prime it's got to be on that line, right?
Yeah.
It's got to be on the line, the perpendicular line formed between the point and the line of reflection, the line that's perpendicular to the line of reflection passing through P, right? So we know P prime is going to be down here somewhere, and we know if that's P prime, that's a right angle, and those are congruent, right? So therefore, the red line is a perpendicular bisector of that segment, okay? And that summarized reflections pretty well. You noticed yesterday, some properties of this, of reflection over the x and y axes. Let's just demonstrate those. I'm going to ask you to go one step further. So let's... what do you got? So that'll be our line of reflection. So now if I, oops, sorry, I'm gonna do this. In Geometry Sketchpad, they just call it a mirror, which makes sense, but it's a line of reflection. And then reflect. Okay, so there it is. All right, so there's our reflection. If we look at the X and Y coordinates of each of these points, I thought there was a way I could do primes on these. I think there is. Okay, how about no whistling? Thanks. Yeah, it does it. See, it shows A prime. I don't know why that says D. It should say A prime. But this says B prime and C prime. Not sure why I did that.
Can you highlight them, maybe?
Should be able to. Let's fix that. So I really would like these to be primes. I don't know what's doing that. Well, it's not that big a deal. Huh. Well, anyway, it should say A prime. I'm not sure why it doesn't. But if I show the coordinates of these as you predicted, based on yesterday, the y coordinate stayed the same, right, if we reflect over the y-axis. And the x coordinates became opposites. Oh, why is it not doing this? Man, I'm having a hard time. There we go. Coordinates. That's what I wanted. Okay, so look what happened to the coordinates. It's hard to see, but notice that they just became opposites, right? Opposite x values are opposites. If I reflect over the x-axis, okay, we get the same thing happening, right? Let me just go ahead and write in some coordinates. So for example, coordinates of A were negative 1, 2, 3, 4, 5, positive 2, right? This should have been A prime. Yeah, they're up there. Yeah, just hard to see. I'll make them a little bigger. So this one was at positive 5, positive 2. And then when I flip down here, what happened? Yeah. Good. Okay. Yep.
Do you like connected all the corners on like the inside of them? They like bisect each other. Like if you had a fourth one in quadrant 4, would like all the diagonals of them like touching, would they like all bisect each other?
Oh, I see what you're saying.
Yeah.
You mean would these diagonals bisect each other?
Yeah.
Well, you're seeing something kind of important here. What do you notice about if we look at the coordinates of each of these originals. So this one was at -2, 2. This one was at -2, +6. Right? And then down here we had 5, -2, -2, -2. Oh, hang on a second. No, you're right, +2. +2, -2. And then +2, -6. Okay, I want you to see, do you notice some interesting things happening here? Just as predicted from yesterday, we see that when we flip over the y-axis, the y-coordinates stay the same, x-coordinates become opposites. Flip over the x-axis, the x-coordinates stay the same, y-coordinates become opposites. But if I do both of those things in succession, what happens? Everything becomes opposites. Yeah, everything flips to the opposites, right? Okay, yes.
Would that be the same as if you reflected it over
Okay, that's
the axis?
excellent question. Okay, so the question is that the same thing as reflecting it over the line y equals x? Okay, let's see. Let's see what happens. So we've got this guy and this guy are the ones we're looking at right now. Let me define a new line here. Oops, it is. Oh, didn't want to do that. Just want to do this.
How many axes are there besides x and y?
Well, in a plane, there's only 2, right?
What
There's only
about
2
there's
coordinate
an
axes.
axis?
Well, there's one coming out of the board then too. Okay, so get someplace where you're not going to be tempted to get distracted at all, because you got to really focus on this. Okay, Alex, turn around. Stay front. So here's the next issue then. Let's test this out. So I'm going to make. Let's cut that whistling, please. Thank you. It's beautiful whistling.
Come on, man.
Okay, so now let's try reflecting our original over the green line of reflection, right? So that's our mirror. Let's take that stuff and transform to there. Well, it didn't match up.
What?
How about that?
Oh, I see it.
Didn't work, did it? Didn't work.
It's the wrong way.
It's the wrong way. Yeah, it didn't work.
That's bamboo.
So we answered the question, though. It was a great idea. So we just found, Alex, that reflecting over the y-axis and then reflecting over the x-axis, or we could have done the opposite order, couldn't we?
Yeah.
Right? Would you agree that if we had done the opposite order, we just would have gone to there first and then to there? Not the same thing as reflecting once over the intermediate line, right? Y equals x. Okay, could we have predicted that, though? And let's think about, let's kind of backtrack. Hindsight's always 20/20. Could we have predicted that maybe that wasn't going to work?
Yeah. You had looked at it.
What's one way?
Well, that wasn't diagonal, you just kind of tipped it a little bit, and it was just up and down. Like you were looking at it differently, not that you actually turned it.
Mhm.
But it would just become the x-axis, and then you could see.
So if I rotated the whole thing?
Yeah.
Okay, it'd be the same effect, though. It's still not going to be the same. And there's one way, there's a reason here for sure that we can show that it can't work. It can't work.
Because, well, like if you look at the side length, you know that
Okay,
the longer side is on the right side,
good.
but on the bottom it's on the left. So.
Good. Okay, so yeah, let's look at the side links here. I purposely made these to be Pythagorean triples, right? So we've got, that's 3, that's 4, and that's 5. So we can track, because it's a scalene triangle, we can see what the orientation of this thing is pretty easily, right? So that's 3, 4, 5. This is 3, 4, 5, and then down here we get 3, 4, 5. Okay, tell me, what were you? Go one step further than that, Em. I think you were saying the side link thing, right?
Yeah.
Okay, what do you notice about that?
Well, I mean, you know that the longer side is like on this half. Like I don't know how to explain it.
Okay.
But like if it was an actual mirror, you could like predict which side was gonna be longer.
Mm-hmm.
Oh,
So
and it would be like the. Yeah, I don't know how to.
no,
explain it.
I think you're seeing something. You just haven't articulated it, but I think you see something. Does anybody else see something about what happens when we reflected it? Yeah.
The shortest side 3 and the other shorter side 3 are facing together.
Uh-huh.
Shouldn't be,
Okay,
since they're all.
Yeah, what happens
it's
when-
Parallel to each other.
okay.
So, if you flip it, then it wouldn't be.
What happens when you look in a mirror? Is it exactly the way you looked at other people? What's different about it? It's backwards, right? It's backwards.
Oh, okay.
Okay, so you correctly, I can't remember who said this, but reflections are isometries. All the measurements are the same, right? The angles all have the same measures and the sides all have the same lengths, right? But we mentioned this briefly, I don't know, a couple days ago. I don't remember exactly what day it was. But when we reflect, something does happen, right? The order in which you encounter the vertices in a triangle, for example, gets switched, right? What I mean by that is if we were going to walk around from A to B to C in the original pre-image, right? We would have to walk counterclockwise to go from A to B to C, right? Okay, what happens with the reflection when we want to walk from A prime to B prime to C prime? Well, we got to go the opposite direction. We got to go clockwise, right? So the orientation is reversed, right? What happens when we then reflect again? What would you expect to happen then to the orientation? It goes back to the original, doesn't it? Right? See that? Now we're going from, so this really would be A double prime, that's B double prime, and that's C double prime. So once again now we're traveling around the outside from A to B to C in counterclockwise direction. So why would it be impossible then to trade two reflections for a single reflection? Because the suggestion was, and it was a good suggestion, was, well, why don't we try just reflecting this thing over 45 and see if we could skip a step? And it didn't work. Can you tell me now why it's impossible?
Because the orientation was only changed once.
Yeah, the orientation would be wrong, right? Because that involving a single reflection is going to flip the orientation once, right? But two reflections will flip it twice, right?
Oh,
So did everybody see that? It's kind of a subtle point, but that's important about reflection. So it doesn't work. Okay?
so like if you, after the first reflection, but then you rotated it down so it's in the other position, it would be the same as a diagonal reflection?
Say it again.
If, okay, so after the first reflection, like across the Y,
Mhm.
right? So it's on the right side of the screen,
Mm-hmm.
top corner. And then you rotated it, would that, like down, whatever, would that be the same as a
Okay.
diagonal?
Okay. Now there's something interesting. Okay, a rotation. Let's look at some other stuff here for a second. So let's pull up. Let's pull up. New sketch. Maybe get rid of all this stuff, I guess. Show grid. Okay, let's maybe look at some rotations. We can do rotations on here also. Let's start with the same kind of thing. Let's go ahead and start with 3 points, same places. How about? So let's see. I think I started there, there, and there. Okay, let's label those. Show labels, good. Let's go ahead and
L.
construct a segment.
P.
Construct.
Really?
Let's do some rotations. Let's rotate this through. Now, when I do a rotation on here, it's a little different kind of a process, right? Reflections, those are going to be, the transformation occurs relative to some line of symmetry, right? Reflections are going to, rotations are probably going to have to be executed relative to something different. Point, okay? It's going to be the center of the rotation, we'll call it, right? So to make things convenient, let's go ahead and make the origin our center of rotation. So I'm going to mark the center, and then let's go ahead, I'm going to put in, I how do I do this? I can't remember. I think I go, oh well, I can't totally remember. I have to mess around a little bit. So that and that. We're going to,
Are they all gonna be around the origin? Or could-
no, they wouldn't have to be. They could be other places too. We're just gonna make it easy at first and then we'll make it a little bit harder after that. Okay, so yeah, we can make an angle, good. So let's just go through an angle of, I don't know, how about like 30 degrees or something? Maybe a little more. Let's go, I'm gonna go negative 60. Okay, so there it is, right? Let's mark these points. Okay, I'll show you here in a second. You'll see it'll make it more visual. So show labels, A prime, B prime, C prime. See them? Okay. There's B prime, A prime, C prime. Oops, didn't want to do that. Oh, didn't want to do that either. What I wanted to do was that. And I'm going to make this a different color so we can see, how about like that? So we can see that it's the new blue, right? To make this easier to see, let's go ahead and put in a segment from there to there. We'll construct a segment, and from there to there, we'll construct a segment. And let's measure that angle. Okay, so measure angle, and there it is. So D is the origin, and it's 60 degrees, right? Everybody see that? What's going to happen if I measure the angle from, let's say, B to D to B prime? Okay, everybody sees that. It's going to be the same thing, isn't it? Okay. And if I do the same thing from C to D to C prime, of course, it's going to be the same also, right? Okay. Let's go ahead and rotate them again. But this time, let's take this one as being. Oops. So that's going to be my center again. Mark center. And let's go ahead and rotate the light blue one. Rotate, and let's rotate this one minus 80. The negative just means I'm going clockwise instead of counterclockwise, right? That's all that minus means. Okay, so there it is. What color do we want this to be? Green. All right. Okay, it's going to be, it's going to be that color. That's kind of bluish. There we go. Okay. And notice now, Geometer Sketchpad's pretty smart. It made that A double prime, B double prime, C double prime.
And there's only one on this class, anyway. Good job.
Okay, so there's my other measurement. There's 80 degrees, we called it, right? Okay. Oops. Here's my challenge to you. Well, first of all, I want you to notice there are obviously isometries, right? All the measurements are the same. But what I want to know now is, did the orientation ever change?
No.
Never changed, did it? We'd walk around from A to B to C, or A prime to B prime to C prime, or A double prime to B double prime to C double prime, counterclockwise the whole time, right? Okay? Everybody agree?
Clockwise.
How does the clock work?
Ladies.
From A to B to C?
Yeah, A to B to C.
That'd be
Oh, clockwise. Sorry, clockwise. Yeah, sorry. Yeah, you're right.
I thought I knew how clocks work.
Okay.
I've only ever seen a digital clock.
So what I want to know then is, would there have been a way to maybe do this with reflections? Could we have gotten from A, B, C down to, let's say, A double prime, B double prime, C double prime? Could we have done that with reflections?
Yeah.
Okay, you think so?
Well, if we did it twice and then
Enough
translated it.
reflections, you might be able to get there.
Okay, let's go back real quick. Let's go back to this one. Make this question a little bit easier. Let's say we want to go from our original. We'll make this one kind of lighter colored. He's just a middleman, right? Let's see. Right. Okay. There's our light blue one. And we'll make this, how about if we make it red so it really sticks out? Could we have gone from the blue to the red in some other way other than reflecting twice?
Yeah, you could have
Yeah.
rotated it, maybe 180.
Okay.
Rotating 180 degrees.
Okay, we could have rotated it 180 degrees. Okay, let's prove that. So here's going to be our center, right? And let's rotate by negative 180 degrees. Oh, what do you know? It lined up perfectly, didn't it?
Yeah.
Right? So we were able to trade 2 reflections for a rotation, right?
Yeah.
Okay, let's go back over to this one for a second then. Can we do the same thing here?
No.
Could we have gone, because this is really the same thing as just 140 degree rotation, right? Everybody agree?
Yeah.
Okay.
Enough lines, you might be able to get in the right spot.
Okay, let's,
You could just do the one reflection.
you think so?
Yeah.
Okay, let's do,
Maybe.
you know what, that's kind of messy. Here, we'll do one thing. Let's do this. Let's go, we want to trade. Okay, so let's trade.
Mr. Oya.
Yeah. Yeah, go ahead.
Oh, what's the end though?
She speaks French.
It's just super professional.
So here's my challenge. Think about how you're going to do this.
No, that's not the same triangle, right?
Is it not the same triangle?
You went 3 over.
Oh, that's fine. Yeah. Okay, so let's make this some predictable number of degrees. Let's rotate this. Let's rotate this, how about 90 degrees? I want you to see if you can trade that rotation for 2 reflections. Okay, see if you can see something going on. This is really cool if you can get this figured out. Okay, there it is, right? So, suggestions. What do you think? You can't reflect it over a point. Reflection is by definition. Ah, okay. So you're suggesting reflecting it over a line through the center of reflection. Okay, let's try that. I like your thinking. Let's try that. Show labels. let's make this red. Okay. So Kirk's suggestion is let's make a line go through there and this, I don't know, like maybe, how about that one? Does that sound good right there? Try that one. Okay. Let's make it smaller. Okay, so we're going to go ahead and reflect this guy. Oops. We're going to go ahead and reflect this guy down here over that line, how about? Let's make this the mirror.
Someone left their ring in the bathroom.
Uh-oh.
I don't know, it looks important. I don't know
Oh,
if it
man.
looks
Just go ahead and set it right there. Awesome. Thank you.
Not me.
Okay, there's our reflection. There's our reflection, right? Any way I could get maybe this guy right here reflected down to there?
Yes. You have to bend the
What do you think?
Reflected nowhere.
To this one down here.
bisect that angle right there.
Ah, okay. Okay, let's see what happens. So if we go... So Gabe, are you suggesting, so I'm going to make a line through, you tell me the 2 points to make a line through.
We'll measure, I don't know what points it would be, but if you make a line that bisects that A prime, B prime, and then whatever that point is,
Okay,
then it would flip right over.
okay. So here's what we can do then. I'm gonna form a line. I'm gonna create a line of reflection. For sure, it's got to go through that point, doesn't it? Everybody agree? So I'm going to make another point down here somewhere that we can move around if we need to. Okay, and we're going to construct a line through those two. Let's see, what do I got going on here? So I need that one and that one. Construct line. Okay? So that's going to be my new line of reflection. Really pay attention because this is super cool. Now we're going to do a reflection of this guy over that line. Okay, but now I should be able to still drag this thing around, right? Okay, I want to get this the reflection to line up with this guy. What do you think's going to happen? Where's it going to have to go? Oh, right there. Has to go through the origin, doesn't it?
That's pretty cool.
That's very cool. Okay, what's special about, so you notice now that each of the two reflections occurred over lines that intersected where?
The origin.
In the origin, at the origin, right? Do you think it even really mattered? Now, what's going to happen if I grab this point and change the reflection around that point?
They're gonna intersect that.
Okay,
They're gonna overlap.
right. Then if I drag this point around, it's going to affect where the ultimate second reflection ends up, right? But if I could anchor that second point to the midpoint of these two, see what I'm saying? Watch this. So if we grab this guy, move it up here, now I don't think I can, no, I can't, okay, I can't do that because I didn't anchor these correctly. That's my fault, whoops. So I'm kind of messed up in one respect here, but make a prediction for me. Do you think it really matters where the two lines of reflection are going to be as long as they obey a certain criteria? What do you think let's measure some angles here. I want you to make a prediction for me. I got to get these to line up just about perfect. So right about there. Okay. We already said, remember how big a rotation this was? It was 90 degrees, wasn't it? So if we measure from A to the origin to A prime, if we measure that angle, it's 90 degrees. Does anybody want to make a guess what this angle from C, I won't do it yet, but you can make a guess, from C to the origin to, let's say, to here is going to be? We want to make a guess? What's it trying to be? Half of 90. Pretty amazing, huh? You get that? Okay. Do you think that's an accident? So look what we did. So we were able to trade. See if we can summarize this, right? You see what's going on here? We were able to trade for a single rotation. We traded 2 reflections. One thing we noticed was that, and Gabe kind of saw this, that the lines of reflection have to intersect at the center of the rotation, because the rotation and the 2 reflections are linked, right? So that's one thing that had to happen. We also noticed that whatever the degree, the angle of rotation was, the angle between the 2 lines of reflection just happened to end up being half of the angle of rotation. It doesn't sound like that could be accidental, does it? Yes, sir.
Does angle AC and then that other point E plus that other point B prime
AC
and the point in the middle?
and the point in the middle? Oh, that one could, I'm not sure. It's possible, but that's not a real important connection. It's possible there is a connection there. But here's what I want to see now. Do you think that we could build, let's just say that we want to do a reflection, we want to do a reflection over 2 lines that are arbitrary but go through the origin. Do you think it's always going to be the case that the angle of rotation is double the angle between the 2 lines of reflection?
Yeah.
Let's see. That's the last thing we got to test. Oh, I think we can do it. Okay, I got to be quick. I won't make this fancy. We'll just kind of go quick here. So there's our original, right? So here's what I'm saying. Let's go ahead. We're going to set a draggable point up here that's going to be, oops, oh, someone. We're going to set a draggable point that's going to define the line of reflection. Okay, so there's a line of reflection. You see what I'm doing? Okay, watch this closely. I'm going to make you guys do something like this on Geometry Sketchpad at some point. So this is going to be the reflection for the line for the first reflection. So we'll mark the mirror, and we're going to reflect. Now we're going to mark this as the mirror. And we're going to have this. Oh, darn it. When I try to go fast, I just mess up. Okay, reflect. Okay, now let's measure the angle between here and
That is not, what the heck? The line,
there.
like, isn't straight anymore.
Okay. So there's A, B, A prime. Now let's measure this angle. Oh man. Okay, and now let's tweak these things. What do you notice?
Wow.
Isn't that cool? Maiden, did you see that relationship? You see what I was getting at?
How hard was the group? Okay. That's because he's gay. Gay? That's because he's gay. Oh, and gay. Pretty sure he's not gay.
Look at that.
Well, just look at that. Oh, it's fancy. Make it dance.
Isn't that cool? 150 and 75. I could just play with this all day.
Bye, Dr. Chen. Bye, Gio.
We doing anything today, Troy?
I gotta look and see what the plan is.
I'm gonna be gone Thursday.
Thursday. I'll be gone Thursday also.
Yeah, Friday. I'm gonna be up at the track meet.
Oh, are you helping out the track meet?
Yeah.
Oh, man. How'd you get roped into that?
Signed up for it in leadership.
Oh, nice. Oh, they are doing that in leadership. That's pretty cool. All right. Let's see. So we gotta go there. This is pretty cool. I'm gonna remind you guys about something really cool in geometry. We just built this last period.
Do you want me to? Sorry.
Yeah, this was pretty fun.
Sorry.
Are you using Chromebooks today?
You guys, you can get them. What's that? You can get them. That's fine.
I have 2 problems I need to get done. I don't really do this.
Huh?
Yeah, I'll do that first. But they're super long.
I don't know.
Thank you.
No. I do.
Can I borrow one?
After on CJ.
Mr. Ray, I'm amazed, or I should move.
Yes, you may.
It's amazing.
When it says lift and shirt.
Okay.
Wait, I thought your game was here.
Well, just because it takes a long time. If we started later, then it'd be late for teams to get calls.
I'm gonna go to Walmart and try to buy
Like, yeah, it takes long.
You do wanna get like chocolate covered. The chocolate is off soon. Yeah, that's got like caramel. That's why I like it.
So this one. Yeah.
We have the lesson then?
Cause I wanted, I said he had these things, chocolate stuff and, sneaky lit.
That's pretty cool.
If you want
So reflection over 2 lines. Oops, want to do that. Reflection over 2 lines. The green angle measurement is the, hang on, let's see, property,
Hey, you know we should grab it.
value, labels.
Nancy, do you know who's in our week right Northville?
Are you third week?
Dude.
I'm third week. I think my brother's in third week. Is anyone else?
Mr. Oya, are we having a work day?
I'm third week right now.
Okay,
Yes.
Okay, I want- how many people are done with the tests? Done with all the tests?
Isn't there just one?
Oh yeah, there was just one. Never mind, yeah.
Wait, what?
Okay, so I'll tell you what, let's do then. I will give you work days Thursday and Friday. Okay?
So we're gonna have to learn something.
Yeah, we're gonna learn something. We'll talk about something today.
James, how easy was that assignment?
Dude, you really third week?
I can't do it.
Okay, just a quick review of geometry here. We just built this last period in my honors geometry class. This is pretty cool. So remember that a reflections, rotations, and translations are isometries, right? All measurements are preserved, okay? But notice that reflections reverse orientation, right? So to go from A to E to F, you're going clockwise, but to go from A prime to E prime to F prime, you're going counterclockwise because we've reflected over this line of reflection, right?
Yeah.
But if we reflect again, we will reverse the reversal, and we're back to the original orientation, right?
Yeah.
Okay? So in theory then, two reflections could be replaced by a single rotation because, of course, rotations don't flip orientation, right?
Yeah.
Does that make sense? Okay, so look what we've done here then. These two reflections is exactly equivalent to one rotation about the origin of the red angle. Okay? Notice what the angle between the two lines of reflection is. Do you see a relationship? Well, more than that.
They equal
There's
something.
superlative. They add
Supplementary, you mean?
Supplementary.
No, they're not quite. It's close, but here, I'll give you a hint. Look at that.
They add to 186. No.
They don't add to 180 or anything, but what do you notice about their relative sizes?
When one gets smaller, the other gets bigger.
They're the same size. What do you want me?
Well, I want you to see a connection between
They
the
add
green.
to something. They're the same. They're the same triangle, but I don't see what.
No, that one's right.
Try to get it right on there.
90-45.
Come on. Oh, I can almost do
Angles
it.
of the triangle.
One of them's the red one's twice as
The red one's twice as big, to within 2 degrees, right? I mean, it's within one decimal place. The red angle is twice as big as the green angle, right? Yeah, the angles. So the green angle, that's measuring this angle right here between the acute angle between the green lines is measured right there.
Yes.
Okay, the angle of the single rotation to get to the red, because the green's actually in the middle, right? We kind of got these flipped around because we did a big rotation, but that's easier to see right there, right?
Okay, so say it again one more time.
So the red is twice the green.
Oh, twice the, up in the corner?
See what I'm saying? Yeah. Okay.
What is that?
I don't know.
That's really cool. What that's telling us is
Angles.
simultaneous reflections over two lines of symmetry. If the lines wherever the lines of symmetry cross, that becomes the center of a rotation of twice the magnitude of the angle between the lines. That's really cool, right? You see that? So we could trade two reflections over the green axes for a single rotation about their intersection,
Yeah, so like angles.
right? Isn't that cool?
Yeah.
But the rotation just has to be twice as big as the angle between, it ends up being twice as big as the angle between the lines of reflection.
So wait, if you started it at like 90, then you.
Right, so for example, if I were to make the angle between,
Then it'd just be a 180 degree.
yeah, if I make the angle between the two lines, like if I make the lines of symmetry the axes, right, so I'm making two reflections over axes that are at 90-degree angles, that's equivalent to 180-degree rotation about the origin.
So if you took the blue triangle, or are we just talking about angles?
I think we're overthinking.
I think a little bit. All I'm saying is if you reflect the blue triangle over that line right there, the almost vertical green line, you get the green triangle. Reflect the green triangle over this other line, and you get the red triangle.
But if you rotate the blue one, you get the red.
Yeah. The angle between, notice that the lines of reflection cross at the origin, right? That's significant. That's the center of the rotation.
So if you rotate the blue one 178 degrees.
Exactly. If
Then
you
you
wrote
get
if you
red.
rotate the blue one 178.8 degrees clockwise, it's going to become the red one, even though I never did a rotation.
Okay, so if you took if you grabbed the angle, the angle of the A on the blue triangle and took it and dragged it around, then it would look
Yeah.
like
It becomes A double prime.
the,
Yep. Pretty cool, huh?
Oh yeah.
Thought that was kind of neat.
So are you just saying though that A is equal to A double prime?
Well, the A maps to A double prime.
But it's not the same because A's only.
Right. Right. Exactly. Okay, so let's talk some physics.
I'll go to baseball short.
Oh, okay. Hey, good luck.
Thanks.
Oh, I don't want to do this when you're gone.
Bye.